Discrete Fourier transform. In the chapter, we'll discuss about computations in DFT. Complex sequence property. DFT of x star of n equal to x star of minus k. That is same as x star of n minus k because DFT results are always periodic results. Let's take one example. This is the complex sequence. So the A part of the question is find x of k. That means find DFT of x of n. So let's do this example in detail. First we'll calculate DFT of 4-point sequence using formula evaluation in terms of matrix form because there are only 4 values. So let's begin with this formula. X of k equal to summation of x of n wn raised to nk, where n varies from 0 to n minus 1. By converting this in matrix form, we get this. Let's substitute value of Pidal factor and the x of 0, x of 1, x of 2, x of 3. Row multiplied by column, you will get a required value of x of k. So we have to multiply row with column and we will get this answer. So final answer is x of k equal to 10 plus 8j minus 2 minus 2 minus 2 minus 4j. So to find DFT of x star of n using x of k, let's say p of n equal to x star of n. By complex conjugate property of DFT, we can write p of k equal to x star of minus k. So it's possible to write direct answer. For that, first we'll write x of k, then we'll write x of minus k, and in this x of minus k, every j will replace it by minus j. So that is complex conjugate. It's a complex conjugate of x of minus k. Here 10 plus 8j will change to 10 minus 8j, minus 2 minus 4j will change to minus 2 4j. Remaining values are real values, so it will remain as it is. This is p of k. Similarly, another example, x of n is given and is a complex sequence. So first we have to find x of k. We have done this. After that we have to calculate DFT of p of n and q of n. P of n and q of n are given in the question. So to find x of k, first we follow this 4-step procedure. Formula, matrix representation of DFT equation, matrix substitution, matrix multiplication, and then we'll get all these required 4 values of x of k. Now, let's say P of n is 1, 2, 3, 4 and Q of n is 1, 2, 3, 2. We have to find P of k and Q of k using x of k. So let's do one at a time. We have to find P of k using x of k. The thing is that to find P of k in terms of x of k, we have to write P of n in terms of x of n. We have to write Q of n in terms of x of n. So let's begin with x of n. This x of n is given here, and this real part of this x of n is actually all the values of p of n. Similarly, this coefficient of the j term, these are values of q of n. So we can say that this is p of n and this is q of n, and therefore x of n equal to p of n plus j q of n. Into j. That means we got this x of n in terms of p of n and q of n. First, to find p of k using x of k, we have to write only p of n in terms of x of n. So to find p of k in x of k, let's write p of n equal to x of n plus j q of n. We have to eliminate this term. To eliminate this term, first we take complex conjugate on both the sides. So here we get x star of n equal to p of n, j replace it by minus j, q of n as it is. Let's add these two equations. By adding this x of n plus x star of n equal to p of n plus p of n, that is 2p of n, and this will get cancelled out. So we can write p of n equal to half of x of n plus x star of n. Here we have to apply scaling property, linearity property, and complex conjugate property. 1 by 2 will remain as it is, x of k plus x star of minus k. This is x of k, these are x star of minus k. By addition, divide by 2, you will get required answer. Similarly, to find q of k using x of k, we have to write the expression of q of n in terms of x of n. That means we'll have to eliminate this p of n. To eliminate this, we'll subtract these equations. By subtracting, we'll get x of n minus x star of n equal to p of n will get cancelled out and we'll get twice of j q of n. So q of n equal to 1 upon 2j x of n minus x star of n. By applying the property, substituting the value, adding the numbers, by dividing 2j, you'll get this answer. This is q of k. Correlation property. DFT of x of n correlation with h of n equal to x of k into h of minus k. X of k into h of minus k. Let's take one example. X of n is 1, 2, 3, 4. H of n is 5, 6, 7. We have to find circular correlation. So first we have to select n and that should be maximum out of these two, that is 4. Append the signal by 0. And then we have to find circular correlation. Then minus h of minus k into x of k, that is y of k. 1 to 1 will have to multiply. And then finally, IDFT of y of k, that is y of k. This is the answer. Let's revise all the properties. A times x of x1 of n plus b times x2 of n is a times x1 of k plus b times x2 of k. This is a scaling and linearity property. Second, periodicity property. If x of n is periodic, x of k is also periodic. Time shift property. DFT of x of n minus m is wn raised to mk x of k. Frequency shift property. DFT of wn raised to minus m and x of n is x of k minus m. Time reversal property. DFT of x of minus n is x of minus k. If x of n is real valued sequence, then x of k equal to x star of minus k. If x of n is even, then x of k is also even. If x of n is odd, then x of k is also odd. This is even signal property and odd signal property. Convolution property. Convolution of x of n h of n in time domain equal to x of k into h of k. Circular correlation. DFT of x of n correlation with h of n equal to x of k multiplied by h of minus k. And complex conjugate property. DFT of x star of n equal to x star of minus k. So the total there are 11 properties.
Coursera is an online learning platform designed to provide high quality structured education in a flexible and accessible way. The platform offers academics and professional courses across science, technology, engineering, and in management. Visit www.coursera.in. Midnight Masterclass is a YouTube channel, and we welcome you to Midnight Masterclass, your late night destination for learning that is actually fun.
Thank you.